All available experts, please report to room A9.
Hey guys, Asew here. Today we'll be going over the module Nifty number. The basic gist of this module is we're going to be adding or subtracting base 36 numbers and giving the answer in base 36 and base 10. Our numbers will be the numbers of the serial number, so we have RM0, UN0. We will split it into two halves, so we have RM0 and UN0, and convert these from base 36 to base 10, and we're going to be subtracting them because there's a subtract button here. If there's a plus on it, we're going to be adding them instead. So we can put the larger one and the smaller one like this. So how do we convert from base 36 to base 10? You could use a base converter, yes, but the way to do it is take the units term, which fun enough in this case both of them are 0. Then we take the next term, which can be converted by taking the alphabetical position plus 9 if it's a letter rather than a number. So n is 14 plus 9 is 23. Multiply that by 36. And finally, take the last one, which is 21 plus 9. And multiply that by the square of 36. Here's our first number. And we're going to be subtracting from that 0. This will be m, so 13 plus 9. And this is r, so 18 plus 9. The second number. Subtracting these two numbers, we get 3, 9, 2, 4.
Emergency cleared. All personnel, please return to your stations.
Do we know what to type into the bottom screen? What do we type into the bottom, the top screen? We're going to be typing in the same thing, but in base 36. We could do this by effectively doing the same thing, but remembering it changes every 36 rather than every 10, like in base 10. So we're going to be having u minus r times 36 squared. We're going to be having n minus m, 36, and 0 minus 0 units. 0 minus 0 is 0. n minus m, they're 1 different from each other, so this goes to 1. And u minus r, this is 21 plus 9, which is 30, and 18 plus 9, which is 27, which boils down to 3. This is our second number, which is the base 86 version. Press the button, and the module is solved. I should do one more example, since it relies on the serial number. And of course, if I did it again, it would be the same answer again. Unless it was a plus.
All available
So let's
experts,
look at our
please
second
report to
example.
room A9.
Our numbers are going to be UM9 and IP4. And today, at this time, we're going to be doing the addition version. So, converting again, units, we have 9. The tens, we have 13 plus 9. And the tens, we have, or the squared term, we have 21 plus 9, or okay, use alphabetical position plus 9. So this is our first number. IP4, aka 4. P is the 16th character of the serial number. Of the alphabet even, not the serial number. So 16 plus 9. And I is the 9th. So it's our second number. And so if we're adding them, we're going to be adding them this time. So our first number is going to be 6, 3, 9, 1, 3. And I'll convert this into base 36. Let's do the addition again. with the base 36. So this is slightly more difficult. Not to begin with, because we're going to have 9 plus 4, which is 13. 13 will become a letter, so let's subtract 9 from that. So the letter representing that is D. Next we have M plus P, which is 13 plus 9 plus 16 plus 9. It gives us 47. What do we do if the number is bigger than 35?
Emergency cleared. All personnel, please return to your stations.
Well, exactly the same thing we do in base 10. We're now going to subtract 36 from this. Gives us 11. 11 translates to a letter, that letter being B. You can see 11 minus 9 gives us 2. The second position is B. So we put B here as our letter, but we carry 1 over to the next column, like you would do for normal addition. So our next one is going to be 21 plus 9, plus 9 plus 9, plus 1. So we have 49. Again, subtract 36 from that. Our first will be 13. 13 minus 9 is 4, so we have D. If you get a 1-digit number, just if the number is that number. And then we carry 1 over to the next column. But I think since there's nothing in the next column, this technically is 0 and 0. Our final digit is 1, so this is converted to 1, D, B, D. Press the plus button, and self-module. So hopefully you now know how to solve a nifty number, and I'll see you guys in the next tutorial.